Tile size and then filled. 1, 2, 3, 4. Got tones all up in here now. Here's one. Hey, there we go. Cool. Some background. Okay. Fix that later. Welcome, everybody. So, enough vaporwave. Yep. So let's see. Today is Wednesday, meaning that we have exactly 1 week until midterm stuff happens. So please check that term project folder and make sure that you are aware which day your teams are presenting, and start planning that out if you haven't already. So let's see. Notifications go away. This is where we ended up last time. So just as a bit of a refresher, we were talking about some of the various relationships in UML, contextualizing it in terms of class diagrams. Again, I know not everybody has seen class diagrams, which, you know, it is what it is. You're going to get it in here. We have had so far associations, generalizations, dependencies. We have had associations, I think I just said that, and then aggregation and composition. This was kind of the tricky one, if you remember, where composition basically implies that the assembly or the whole will be responsible for creating and destroying its components. Aggregation, the parts are responsible for themselves, if you need a reminder of that. And again, keep in mind that all of these line types, arrow types, they all have meaning to UML. So please try and focus on whether it's dashed or solid, what the arrow type looks like, because again, if you give a UML diagram to somebody, they're going to be expecting that syntax. You can be a little bit flexible in terms of like how you write stuff on here, but just make sure that you're not giving the wrong impression, like with your line types. Right, for instance, here, if you filled this in just thinking it'd be a composition, would it be okay? It wouldn't be a huge deal, but you would be basically telling the reader that, okay, well, the department's in charge of destroying the instructor classes, whereas here, the instructor is responsible for itself. Again, just keep in mind, these things all have meaning. That's about where we ended up. So I left you with this example. I have another one here as well, where basically we just have different examples of association. So here we have some aggregations, some compositions here. One thing which is slightly different is that we can have kind of this feedback loop type of structure where basically we can do a self association. So here we have a self aggregation here where a team can be made up of subteams, right? Or components can be made up of sub-assemblies. There's nothing wrong with having an association to yourself. It will basically show kind of a, building up of parts, or maybe you have a dependency on yourself, like another version of your class or something like that. So we will get some practice with class diagrams too. So if you're a little bit unsure of how this all kind of fits together, don't worry, you will get some activity with that to help you out with that. So the last association we're going to talk about is a realization. This looks just like generalization, right? Except the difference is it's a dashed line instead of a solid line. We only have so many line types and arrowheads that we can play with. So here, what this basically implies is that you have an interface and a class. Now, we haven't talked about interfaces yet. Basically, this is just a way to provide access to another class. So here you're kind of specifying what's called a contract. And we're not going to go into too much detail on contracts. That gets a little bit too detailed for where we need to be, I think. But basically, this realization relationship is basically specifying what has to happen to access this particular class. So I've got an example here And this is called the canonical form. We've got a slightly different view. Actually, it's a good reminder because I need to move my tiny little head up here for the next slide. But basically you have a class, and then you have an interface here. And we denote it with these two angle brackets, and interface. Looks like a class diagram, can have attributes and methods, but basically this is a way to access this particular class. All right, so we may have some business rules that we've defined for accounts. And this can be just, how accounts are managed, maybe how you update them, destroy them, acquire them, right? It's a thing that we have to do. However, this might be private to our internal company. And if you want to access it, you need an interface to do that. So this is realized, right? So there's a realization by an interface. And if I want to handle any business rules, I have to fulfill whatever operations are specified here, right? So if I want to add a rule, I talk to the interface. I don't talk to the actual class itself, if that kind of makes sense. So basically, think of it kind of like a level of abstraction where we talk to this, not to this, in a way. And that's a gross oversimplification of what interfaces are. But it still functions like a class, right? Still has attributes, methods, things of that nature. Now, to put it all together, we have kind of a high-level class diagram here. And there's a couple of things to talk about with this particular model. Let me make sure my timing's going to be good here. So we have our classes, right? So each one of these boxes are classes. Some of the classes have attributes. So it's going to be this first box container inside of a class. These are your attributes. Again, attributes are going to be the field types, basically what your variables are, and then what data type they are. So for instance, here you have an integer, you have a string. These are all baked into most languages. Here we have a name. Now, a name could mean anything. Most likely it's going to be a class or some kind of a subclass in here. And ideally you would see like a name class defined and kind of related to department and person and all that. But that's where you define your attributes at the top. And then the next box, you define all your methods for that class, right? So typically it's going to be the method name, the method data type, like so what return type you're expecting. You'd specify it similar to attributes. That's not specified here because I assume that they're void or something like that. And then any parameters that are going into it. Some of these don't have attributes or functions, right? No methods, no functions here. That could mean a couple things. One, maybe we're not sure what company needs, or we don't know what headquarters needs. Maybe they're unimportant to this diagram. Right? Maybe they just don't need to exist. So you can simplify these diagrams in any way you choose, really, as long as you get the intended information across. So with this, we have a bunch of other things too. So down here, this is kind of the slight difference. So this is called a lollipop notation because it looks like a sucker, basically, but this is just the same as before with this realization. So if we had this interface in this class, here's your interface, here's your class, or sorry, here's your interface, here's your class. So the lollipop is basically just kind of a different way to demonstrate the realization here. So here we have an interface I secure information. Interface is typically prefaced with I to denote it's an interface as well in the name. But here we'd have some rules for how we access personnel record. And let me do that because that will be helpful for viewing things. Okay, so we have interface, we have our boxes for classes. We also have all of our relationships, which we've been talking about right for the past class and up till now. Here's your aggregations. Here's a generalization, dependencies, associations. We have a constraint here. We have our multiplicities. We have a little bit of textual information here. We have a role. So basically you get a lot of information that you can take to your implementation level with a class diagram. That's kind of why they're so helpful. You've gone further and further down the levels of granularity, and now you have something that's pretty darn close to actually writing code, right? So what else do we have in here? So here we have some compositions, right? So the filled diamonds. A company is made up of departments. A company is made up of offices. So this is our whole. These are our parts. A department can be made up of other departments, right? So you have different sub-departments. Let's look at it from this perspective. So we have one company. We can have one to any number of departments in the company. We can have one to any number of offices in the company. Since it is composition, the company class is responsible for the department and responsible for the offices, right? If I create a company, that company creates the departments. We don't just create them and let them float around and then assign them to a company. It's all very tightly coupled. If it was aggregation, they would be left to their own devices, basically. All right, so what else do we have here that's important? We have a generalization here. So this is a nice example as well. We can have any number of offices, right? So again, this is like you're building an ERP system for a company where you add in all of your building information, your employee information, payroll, effort, everything to manage your company. And this is a very simplified view of this, obviously. So we have to define our offices. Where are they located? How do we call them, right? What's their phone number? We may have special types of offices called headquarters. This would be a generalization here, right? Because headquarters will have an address and a number. In this view, we don't have any special characteristics, but we could add extra attributes here, right? We could say headquarters are the global headquarters or the regional headquarters. Maybe there's something special about a headquarters office that needs to be tracked, right? We would put that in here. Now let's say that we have a category of headquarters, for instance, and we make it an attribute. Offices will not get that attribute, right? Because it's specific to headquarters. Offices have this generic interface, or this generic setup here. So hopefully seeing some of these relationships in kind of a bigger example is a little bit helpful of how they all kind of work together here. Here we have a dependency on a person. Let's say we want to get their contact information, right? We're doing an address lookup. Well, we call the person's get contact information function. Well, that has a dependency on a contact information class. We want to get their personnel records. That has a dependency on the personnel record, which if we're internal, maybe we can directly access it, or we have to talk to the interface. This depends on, I guess, where you are in the system. So for this diagram, I don't have the specific syntax in the slides for how to put one of these together. I'll upload that separately when you have some work to do with class diagrams. But it should be hopefully pretty straightforward, especially if you're doing things in Java where everything is class oriented anyway, right? This is my class that I've defined. Here's all the variables. Here's all the functions. What classes does it relate to? Now, one thing you might notice in here, I don't see any of the common functions, right? There's no gets or sets. There's no creates or destroy, right? Those are all assumed to be in here. Common everyday functions or return types, like a void type of thing, you don't have to put them in here because it's assumed that it's there. Once you start adding special features, special characteristics, then you have to add it in. Otherwise, you're going to be losing out on information. Yeah. If this doesn't make sense, or if you have any questions, please feel free to pop it into the chat and I will answer them as I see them. Oh, I've got some pop-ups here too to kind of help. So again, we have our multiplicities. So again, asterisk is any, or number dot dot asterisk is a range. The name of the class goes in the top. Then you have your generalization here. Roles. Now, are roles important for the coding, or are attributes or like association attributes important for coding? Not necessarily, but it can be helpful for things like the meaning of what it's doing, if you're communicating with somebody. So this constraint field I haven't really talked about yet. This is something that you can put on any association in any diagram. Basically, what has to occur in order for this association to be valid. All right, so here, This is a constraint. Let me get rid of all these arrows so we can see a little better. So we have a department here, right? So we're going to create a department object, and we're going to have people attached to our department. Now, we're going to have 1 to any number of people working for us in this department, but we're only going to have one manager. All right, so think of a business environment. You have a department. That department has a manager in charge of everybody in the department, right? However, the constraint here is subset. And what does that mean? Well, the manager has to be a member of the department. Makes sense, right? If you're working in, say, the School of Computing and Information Science, that's our school or our department, the manager would have to be attached to that department, right? It'd still have to be a person, still a member of the department, but we have a special role that, maybe we have different attributes for, or different access roles or something of that nature. So here, hopefully you get a good feel for all the different things that we can put into a diagram. All right, so some questions for you. First one I will ask and then I'll wait for a response. So just so you're aware, when would you use class diagrams? All right, so other than your manager telling you to make one or your professor being mean and giving you a homework assignment on class diagrams, say you're working for a company, you're going through a software process, I don't care which one, when would you do the class diagramming? Like at what phase of the project would you go ahead and do this? Prior to sitting down and coding, hey, I like that. So before you actually write any code, early on, I like that. Any other answers? I asked this in my morning class and I got a wide range of feelings on this matter. So keep in mind, this is structural, right? So it is close to the implementation level. We are nailing down the static aspects of our system. Anybody have any other guesses? Give it a second here. Middle, after you have a framework of your project. Also a valid answer. So the key here is that depending on your phase, you would probably be working on a class diagram, honestly. So let's start with the first answer here, prior to sitting down and coding, early on. So probably somewhere after requirements elicitation or right around there, right? Sure, absolutely. We can get an early idea of what our project is going to look like. So let's pop back here a little bit. There we go. Nope. No? Where? Hey, I had a diagram here that I wanted to show. Here, this one. It wasn't that far back. So here we have an early class diagram. Right, so let's say that we're mapping out a school and everybody attached to it. Here we have an idea of what classes we need. We have an idea maybe of the relationships between the classes. Oops, didn't want to do that. But we don't necessarily have all the attributes here, right? We don't have all the methods that we may need. So this could be an example of an early class diagram. Now, is this the end-all be-all of class diagrams? Well, no, we would refine it over time, right? So before you sit down and code, you should have a good plan. So that's an absolutely great answer. But after we start making the diagram, then we start refining it, right? So let's say that we have our framework, we have our idea. Then we go back to something like this, because I like this one. Now maybe we're further on in the project, we have better requirements, we have better use cases, we have some of our behavioral diagrams in place, and then we start figuring out, hey, what are all the attributes, what are all the methods? What are all the attachments to our associations, and what maybe a clearer idea of association types? Right, so we have kind of a way to refine these models over time. So arguably, you would use it at all points. And if you have a good class diagram, there's no reason you can't go back and refine it later on. So the second question then, what type of process would you use with class diagrams? And if you wanted to do diagramming like this, would it have to change the process? And the answer here is going to be no. Because if you're doing waterfall or agile or prototyping, throwaway prototyping or spiral or any of the ones we talked about or any of the others out there, right? Like extreme programming is part of agile or Scrum or Kanban, does it matter? And the answer is no, because if you remember, UML was developed to be domain independent and process independent. So if you create a class diagram for a project, it will apply to an agile project, it'll apply to a waterfall project, it'll apply to any project, right? Now, depending on how the industry kind of ebbs and flows, you might have a specific type of class diagram that you prefer for Agile, right? Maybe UML is not what you need, but you want some other variant, and Agile kind of gloms onto that because it's very fluid. That's fine, but you're still going to have something that looks like a class diagram at some point. So definitely kind of a good activity to get a handle on. And even hopefully for your term projects, if you haven't done any class diagramming, obviously I haven't asked you to. But if you look at something like this, right, let me pop out all the stuff here. This is something that you can share with your team. People can work on different classes, and then you know how they all will link together. Right? There's a good chance here that even, if one of you works on the person, one of you works on the interface to get secure information, you're going to know which functions to call to get that data. Or how many departments you have to instantiate for your project, right? Assuming you're doing a school-related thing. So then last year, there are a lot of automated generation tools out there, and I mentioned this last time, right? If you use Eclipse or you go to JetBrains or any of the big IDEs or even some separate tools, you can plug in a class diagram and generate code, or you can take your code base and automatically generate class diagrams. You can take that, generate use case diagrams, generate basically everything can be automatically generated. However, there are some pros and cons with doing this, and I'm wondering if anybody has an idea of what some of those pros and cons may be. So let's say that you write all your code, we're doing our flying by the seat of our pants coding for the semester, and your mean old professor says, I want a class diagram now. So you're doing it in Eclipse. Robot's taking our gerbs. I like it. I added the gerbs. And you so like, okay, well, I'm just going to use Argo UML or Papyrus and just automatically generate a diagram. Other than the machines taking over, is there any problem that you might see with this? And I should probably add the caveat that if you've never done this before, you might not know what the pros and cons are. It's kind of one of the things you have to experience. He said, needing more coffee. All right, so let's assume that we're okay with robots taking our jobs, right? You are a speedy engineer and you need to get something done quickly. Does it do it correctly? You have to have the UML exactly correct. So that's definitely one problem. If you are not fully up on your UML syntax, it's possible you make a mistake. Maybe you forget a connection and it spits out the wrong code or the wrong diagram, makes the wrong associations. So yeah, that's definitely one thing. You have to have your UML syntax on point. The other thing too, it does help. By and large, you're not going to get the full picture though. So like you might get function stubs that are empty, right? Nothing populates them. It's still up to you to fill in the code. Or you have diagrams which become overly complicated. Or. Basically with an automated tool, you just have to be careful of what you put into it because what you get out of it is not always what you're expecting. Yes, it's quicker, but sometimes it takes more time to fix the problems that are automatically generated. Maybe you have a very complicated code base, like those of you doing Unity or Godot games. You probably have a lot of classes, a lot of interactions happening, and you try to automatically generate a class diagram. You're going to get this massive PDF of a whole bunch of things connected to each other. And that gives you a whole picture, but not like maybe a deep dive on what you're expecting to see. Or it's broken, or, there's lots of things here. Basically, It can be a good thing. You just have to make sure that you're okay with automated generation, because you don't always get what you want. But before I go too far off the rails on saying this is horrible, if you do use one of the generation tools, typically they have a built-in like parser. So for instance, I know Papyrus in Eclipse, which is one of the plugins that you can get. It has its own UML tool, so you can't really like do it wrong. Like it'll tell you if you break something. And there's a lot of crazy academic tools out there which are in the research domain, which do pretty good, but they're finicky because they're academic stuff. Not always validated for all situations. All right. Excuse me. So we talked about class diagrams. We'll come back around to it when you all have work to do with that. But now we're going to talk about objects, and this is what I get when I search for object in Unsplash images. And now I'm hiding text again. So let's move me back down here. So an object diagram is basically just an instantiation of a class diagram. And put all this up here so we can talk about it. Now, take those diagrams and the relationships that I just showed you, put some values into them, and you have an object diagram. So you are instantiating things. So I've got a whole bunch of text, so it's showing the static part, it's a snapshot at a moment in time. Basically, all you're doing is we're going back here, filling in some values. What's the company called? What are the departments called? What is the address and phone number of this particular office? Who is this employee? All right, so we're filling in values here. So here's an example. This is a kind of straightforward standard UML example here. We have created a dog class, right? So the class is basically a prototype of what a dog will be when we create one. All right, so here's all the properties we've specified. Here are the methods we've specified for this class. So a dog has color, so that's its fur, its eye color, how tall, how long, how much it weighs. Here's the things this dog can do. That's the class diagram. The object diagram is an instance of the class. And this is something that you sit down and do in a UML modeling tool, or you do it by hand on paper. So it's yellow. It's got brown eyes. It's 24 pounds. It still has the same methods because we're just instantiating this particular dog called Bobby, for instance. What's the benefit of doing this activity? Question to you all. Right, so we have one class here. Consider that we can also do it for our company class, set of classes, right? Where we're instantiating things. We're showing relationships, right? So for instance, here we've created a company, we've instantiated some departments, we've added a person, and this person is a manager. We have an anonymous object that we get from our interface. What's the benefit of going and doing this? Seems like extraneous work to me, right? Because you're going to be doing this in the code, right? You're going to write a for loop, run through a database, pull out all the values, stick them into your class instances. Why do I have to do this by hand? So it's a very good reason for doing it. I will give you that much. I'll give you a dancing crab to help you out. I'm starting to memorize the emote shortcodes that come out of TTV. I'll drop the question in the chat just in case. So why do we do this? It's a very common software engineering activity. To organize your classes. Okay, so that's definitely could be one reason. So let's say we create an object diagram, visualize how pieces of data interact. I would probably put those two answers together, right? So organizing them or visualizing relationships, basically. So yeah, we can definitely see how data interacts in here. Right? Yep, so those are good answers. I would definitely say visualizing relationships is a good one. Let's go back to this dog example here. Are these the only things that a dog can do? Sit, lay down, shake, and come. No. Dogs can bark. Dogs can sleep. Dogs can breathe. Depends on how deep, obviously, you're going into this dog simulation. But what we might be finding out here is that we're missing data, or we're missing methods, or, like to your points that you answered, we're missing interactions. Could be that this data type is incorrect. Yeah, can't play dead. Dog doesn't know how to play dead. It's not one of our methods. Thing is, though, that if you find that you're missing something, instantiating them in an object diagram will tell you. Because, you know, we might be expecting a particular attribute to act on it later. For instance, here it's pretty clear, right? We're doing a very high-level view of a dog, but maybe we want more information because we're making what was that Nintendo game, Nintendogs? We need a little bit more data than just sit, lay down, shake, and come. What about play or roll over, play dead, or any of those things? Or we're missing information on, other things. So if we were missing information at the class diagram level, could be that we've already implemented it and we need to add some new fields. Okay, we add new attributes, fine, easy enough. Well, we have to update our class diagram. Okay, we've updated our class diagram. How does that impact our other diagrams? Do we have to update our use cases? Do we have to update our sequence diagrams, which we'll talk about here in a moment? Do we have to update our requirements or add new ones or remove them? Do we have to add new test cases tied to requirements? Right? This all is linked together. And as we go through this refinement process, and this is basically refining your class diagram, we discover things that are correct, that are incorrect, missing, mistyped, right? So this is basically an exercise in trying out your diagram. So when do you use them? I mean, obviously after your class diagrams are created, otherwise you don't know what to instantiate, right? But you can use this all throughout the software process too. You can do it at the very beginning when you're planning your framework out, right? You don't necessarily have all the attributes or methods in place, but if I have, I want to model a bunch of animals, I have an animal class and all the subtypes. Well, what attributes do I need to create Bobby the dog, right? And this is where we can start refining. A good question you might want to ask, though, is how many object diagrams do you need? So let's say we look at the dog diagram here. How many object diagrams do we need? And the answer is going to be however many you think you need. There's not a firm answer. Basically, what you're trying to do here is exercise your diagram. And what I mean by that is try it out in multiple ways to see if you're missing something. Here it's pretty straightforward, right? You have one class, one object. We get pretty much everything we need out of that. But here, we have a lot more dependencies going on, right? We can have multiple departments, we can have headquarters, we can have different types of people. We might be interested in their personnel records, maybe their payroll. So you don't necessarily need to do just one or just two, but you should do enough to get a feel for what your system is going to look like at runtime, if that makes sense. You exercise your model by trying out all the edge cases, right? In this object view, we only have one person in the department, right? We have Aaron. Aaron is not managing anybody, which is a little bit weird. Do we need to maybe have at least one employee underneath the manager? That'd be a question that you could ask when you look at an object diagram like this. Do we need staff that are, not engineers? Like, do we need administrative assistants? Do we need particular roles for our engineers? Now, these are all things which you can kind of ask yourself as you start making these diagrams. Do the relationships make sense? Should we create a single employee class and generalize off of it like we did with office and headquarters? So how many do you need? As many as you think you need. All right, so that is it for structural diagrams. Hopefully that makes sense for everybody. Again, we'll come back to class diagrams with a little bit of formality there. But now we're going to get into the behavioral side of thing. And we're going to look at sequence diagrams, which we'll get into today and we'll probably wrap up next time. We have communication diagrams as well. And these are basically two sides of the same coin. So semantically, meaning like the intent, they're basically equivalent. They're just showing you a different perspective of messages and time. And what's a message? Message is something that you're going to hear multiple times in the behavioral diagrams. A message is basically a function invocation, right? So I'm calling a function. That function may pass data from one object to another. So we're basically sending a message from one object to another with these types of behavioral diagrams. And we care about timing, we care about order, and we care about when objects are alive or dead. So a few different things here. Again, this is the dynamic side of things. So class diagrams, sequence diagrams have a few distinct things, and I'm going to pop up an example here where I'm going to show you what these 2 points are. So object lifeline and focus of control. So your object lifeline is this dashed line going vertically. So this is your lifeline for each of these objects, right? These are the things. So these guys at the top have different view or different symbols. I'll talk about those in a moment. These are the objects active in your system. And the dashed line is their lifeline, basically when are they alive. The little thin rectangle, this is your focus of control. It's also called an execution box, something like that. It's got multiple names. Basically, this is when this particular object is interacting with something, is this the simplified view. So here we have a person. So we have an actor called Osbert, which is an amazing name. We have a boundary class. So basically this would be an interface type of thing where this little line here is a boundary. And I've got a link here for the boundary pattern if you want more. Basically, I talk to this backend through this interface is what this means. I have a boundary. I have a control object, which basically is in charge of accessing data. And then I have various entities here. So these all mean something. You're not necessarily always going to need each of these object types. You're probably just going to have people, or in this example, just boxes for classes. But it's good to see like all the different types you can have. All right, so how do you read this diagram? Because that's kind of the big thing here, right? You start at the top left, and then you follow the arrows, and that's all you have to do. The arrows are going to be how messages are passed from object to object over time. Typically, you'd have like a function call on this arrow, or be a little bit more verbose to give an example of what has to happen. So here, Osbert wants to buy some artwork at an auction. So he wants some details on this particular piece of art. Well, he puts this query out there. Let's call it maybe a virtual art auction since we're, everything's an instantiated class. He puts his request into the system. The system talks to this interface. Right, the interface is going to transfer his request to a control entity, which in turn is going to instantiate this object inside the system. So we have a piece of art, hasn't been instantiated yet. So by calling this function, we get a new class for this particular artwork with all the attributes that go with, whatever's important for art. Here we only care about money and probably name or something like that. So this object gets created, and then that object gets returned, right? So you can see again how objects are interacting over time. Compute masterpiece price class here needs a reference to the object. It gets that object. It might look at auctioned paintings. So we might have another flow here. But based on what we've seen auctioned, based on this particular piece of artwork, we'll get a price. Again, this could be any example. We're just showing flow. So the price comes back. Right? So we provide the price to the interface displays it to the user, right? So we have a level of abstraction with this particular object. Now, Osbert here hates the price too much. He rejects the offer. Okay, fair enough. The masterpiece class gets destroyed because we don't want it anymore. And we're destroying the instance, right, not the class. When that gets destroyed, we can put a little X here at the bottom saying that this particular object no longer exists in memory. And then control goes back to the user waiting for another input. This is a pretty complicated one with different types. I like them that look like them that look. I like ones that are a little bit simpler, more close to an implementation type level. Basically what you're doing is just communicating between objects is kind of your hot take from what the purpose of these things are. Here we have a different view at the top, right? There's no stick figures, no circles with wonky lines on them. We just have classes. So here, there's a little bit of common formatting for this. So if you have a colon, the right side is the class name. If you have a left side, it would be the instance name. So if I had an actual person here that I was instantiating, this could be like Eric customer. Or it can just be a generic class, right? It just depends on what you want to show to people. So here we're doing an operation of getting money out of an ATM. And actually, it's even simpler. We're just verifying that the card works okay. So a customer, right? Lifeline for the customer, lifeline for the ATM, lifeline for the server behind the scenes. Customer puts in their debit card. So actually a function call here, right? This function call would be attached to customer. I put my card in. The ATM object takes the card, right? So we have control at the ATM now. ATM will call check card. And for some reason, this parameter is in German, but this is in English. Just okay. We'll assume it's fine. It's going to call check card, pass in the date, probably the date of expiration of the card, and what return type maybe we were expecting back. Right, so we're going to pass this call off to the server because the server is going to do the important computation. The server is going to do whatever it has to do internally, and then it's going to return a value. The ATM then will return a value back to the customer. So you can kind of see how control gets passed along. And why are there no values on these lines? Because honestly, for this particular interaction, what you want to get out of it, we don't care. So we're not going to show it, if that makes sense. If you want to put more information, it would be good to show, okay, what's the data type coming back? Is it true or false? Or is it an enum? Or is it a value, right? So more details are usually good, but this is a very simplified picture here. So to kind of summarize, sequence diagrams, start at the top left and just follow the arrows. In this particular flavor, the actions, the methods that are being invoked are solid lines with arrows, right? Solid line with arrow. And then the return value is going to be a dashed line with an unfilled arrow. So this is more of a common UML representation of a sequence diagram. This one is a little bit, well, it still has dashed lines in here, but it's a little bit different than what I would commonly expect here. So Does this make sense in comparison to like the structural diagrams? Here we're showing flow. What functions get called to take you from basically state to state? And who is in control of what data when? Now, can you have a class diagram without a sequence diagram? Can you have a sequence diagram without a class diagram? You can, but there's going to be a lot of loss of meaning. Right, so if I have no class diagram, these boxes are not going to make any sense. Right, so we're going to assume that a customer exists, but how do you know if they have this method? Or how do you know if this method exists? Or, you know, card date. Does that exist as an attribute? Is it a parameter? You know, we have no idea without the actual diagram backing this up. So I do have some formalities here. There's nothing behind my my video if you're looking at it on Twitch, which I don't know where else you'd be looking at it. But some definitions for you here. This is what I'd provide for the class diagram as well. But you have your actors, you have your objects, you have your lifeline. Execution occurrence, that was the phrase I was looking for. This is your focus of control, also known as kind of thing. Your messages. Object destruction was that X. You can put a frame around things, so you haven't seen that, but basically I would put a frame around this with a description of what the sequence is supposed to represent. So like I'd put this frame, and context would be check bank card or something of that nature. And then the only other thing that we didn't really talk about is this guard condition. So this is important for making sure that this flow of data can happen. Think of it like an if test, right? If card exists, then check card. If card does not exist, then do a different branch. So that is pretty much all the time we've got for today. So we covered sequence diagrams, wrapped up class diagrams. Anybody have any questions from our material? Everything makes sense? Hopefully more or less. You will get some practice with these as well, so don't you know, don't feel like it's going to be a one-off type of thing. But that'll be after your midterm. I don't want to overload you all. Even though I know you could do it. You have enough on your plates right now. All right. If we are all good, I will see you all on Friday, right? Today's Wednesday. Yep. And we will wrap up UML and maybe start talking about design patterns. So, have a wonderful day. See you Friday. And yeah, I don't have a cool outro yet, so probably don't need one. But have a wonderful day, everybody. Bye.